Vanakkam one and all. So in problem number 10 of exercise 5.1, we will find the points of discontinuity of the function where the function has been defined like this. So for all x greater than or equal to 1, for f of x will be x plus 1, and for all x less than 1, function is x square plus 1. So now let us draw a real line to know the domain of the function. It's a real line. So we have 0, plus infinity and minus infinity. Now we have here 1, 2 natural numbers, here all negative integers. Okay, so when the value of x is greater than and equal to 1, so which means this interval, this part. So in this part the function is x plus 1. So for the closed interval 1 to infinity open. So for this subset, for this part, the function will be x plus 1. And whenever the value of x is less than 1, which means we won't consider the point 1, okay, and just the numbers which are less than 1 and up to minus infinity. So we'll have minus 1 to minus infinity. So you find union of this. That one will be the domain of the function. So domain. This domain of f of x is nothing but a real line. So whenever the values of x less than 1, our function will be x square plus 1. So the function has been defined on real numbers. So but they have made the changes at the point 1. Okay, up to 1, before 1 we have x square plus 1. At 1 and exceeding that, numbers exceeding 1 will have the function x plus 1. Okay, so now we will consider an element, okay, x, for all x less than 1. For all x less than 1, f of x is x square plus 1. It's a polynomial. So polynomial, we know polynomial functions are continuous, which implies f of x is continuous for all x less than 1. And consider about for all x greater than 1. So when the values of x are greater than 1, in such cases the function will be x plus 1. So again it's a polynomial. Okay, so since f of x is a polynomial, it is continuous for all x values greater than 1. So in this domain, I mean the function is continuous at 1 to infinity and minus infinity to minus 1. Okay, so the function is continuous. Now we have to check the continuity at 1, at x equal to 1. What about the functional value at x equal to 1? When the value of x is 1, the function will be x plus 1. So f of x is x plus 1 when the value of x is 1. So we will get 1 plus 1, which is 2. Now we will calculate left hand limit and right hand limit of the function. So limit x tends to 1 from left hand neighborhood. So from left hand neighborhood of 1 means this portion, the values are less than 1. So the function will be x square plus 1. So x square plus 1. So after substituting limit we will get 1 square plus 1, which is 2. Now we will calculate limit x tends to 1 plus, which means we will approach that number 1 from right hand neighborhood. So here the numbers are greater than 1. So we have to take the function as x plus 1. So for the function x plus 1. So after that we can substitute the limit. So 1 plus 1 will be 2. Here left hand limit exists and right hand limit also existing, and those limits are equal, and they are equal to the functional value of x. X is 1 here, which says f of x is continuous for all x belongs to R, which means there is no point of discontinuity. So there is no point of discontinuity. Okay. Now we will discuss problem number 11. Here again they are asking for the points of discontinuity of f of x, where f of x has been defined like this. Now to know the domain of the function, we will draw a real line. So that real line f0 and right hand side up going up to infinity, left hand side reaching up to infinity, going on and on. So 1, 2, 3 natural numbers, negative integers. Now here the function will take x cube minus 3 when the values of x is less than or equal to 2. So less than and equal to 2. So in this part the function will be x cube minus 3, and once the values are greater than 2, it will become x square plus 1. Okay, and it says the function is defined for all elements of real line. So domain of the function is domain of f of x is R, real line, entire real line. Now we will check if we will consider the value of x as less than 2 for all x. Okay, less than 2, f of x will be x cube minus 3. It's a polynomial. It is a polynomial, which says the function is continuous for all. It's a polynomial, which implies f of x is continuous at 2 to minus infinity. Here now we will consider x for all x greater than 2. So greater than 2, where the function is x square plus 1. Again it's a polynomial. So it will be a continuous function, which implies f of x is continuous at 2 to infinity, open interval. Okay, so now we have to consider the continuity at 2. So we'll consider at x equal to 2. F of x will be, when the value of x equal to 2, we can take f of x as x cube minus 3. So functional value will be 2 cube minus 3, which is 8 minus 3, that is 5. So 5 is the functional value at 2. Now we will calculate left hand limit. So limit x tends to 2 from left hand neighborhood. So in the left hand neighborhood of 2, okay, so in the left hand neighborhood of 2, which means this part, the function is x cube minus 3. So I will take x cube minus 3, which is 2 cube minus 3. We will get 8 minus 3. This is nothing but 5. Now we will consider limit x tends to 2 from right hand neighborhood. So in the right hand neighborhood of 2, we have the function x square plus 1. So I mean in this part, from in right hand neighborhood, the function is x square plus 1. So we will substitute x square plus 1. We will substitute x as 2 over the expression 2 square plus 1 we are getting. As a final result is 5. So here in this case at 2 we are able to get left hand limit and right hand limit, and those limits are equal. As well these are equal to the functional value f of 2, which says it is nothing but limit x tends to 2 f of x equals to f of 2. Therefore the function is continuous at 2. So f is continuous, f of x is continuous continuous on entire real number. So there is no point of discontinuity. So there is no point of discontinuity for this particular problem.